All right, so let's formalize the definition of splitting field now. A subfield sigma of C is a splitting field for the non-zero polynomial f over a subfield K. Oh, that was just got away from me. If, well, first of all, sigma needs to be an extension of K, and f splits over sigma. Okay, so it should be a splitting field, so it should be a place where the polynomial splits. That should be a condition. And two, if you thought you had another field, or if you had another field, sigma prime, and f splits over sigma prime, and sigma prime you thought was maybe less than sigma, well, then actually it's not. So this is another smallest condition. This is like saying that sigma is the smallest extension of K, that's this last part, over which F splits. So there's no smaller field, subset containment wise, over which F splits. Now, what we need to do to have access to the roots and minimally have access to the roots, so I'm going to call this condition 2 prime, which is an equivalent condition, is that sigma explicitly is K adjoin little sigma 1 through sigma n, where sigma 1 through sigma n are the zeros of F. So all we're saying is to form a splitting field, of a polynomial, we just add in all the zeros. Okay, that's all we do. All right, so let's just quickly revisit these examples that we looked at. Here, L is the splitting field for this polynomial f here. So this guy here is a splitting field. And similarly, for this example that we did, the L is also, let's use orange maybe. This is also a splitting field for f, because we added in, well, we actually didn't even need to add in all the zeros, because adding in some of the zeros gave us access to the other ones. Okay. Now, as a non-example, C is not a splitting field. Well, let's use blue. Of the polynomial t cubed minus 2 over q. And while it's true that t cubed minus 2 splits over c, it is not true that c is obtained from q by adding in the roots that we need. This is not true. This is false. Right? Because there's so many other complex numbers out there. So it's not the minimal field over which this polynomial splits. There is a significantly smaller one, even smaller set theoretically. You know, the right hand field is countable, C is uncountable. So splitting field is the minimal field, minimal under subset containment, such that our polynomial splits. And it is constructed in a very simple way. We just take the base field and we add in all of the zeros. We adjoin the zeros.